Okay, so this is the second page of your 3.4 graphs of exponential functions notes. And when you look at this general form of the equation, the a is still the same old multiplier that it used to be. So that's going to make the graph either stretch or compress, just like it did before. Now, one of the nice things that you get to not worry about is b is now your key point maker. Okay, so does it reflect or stretch? No, it makes the key points. Don't forget that A can also reflect. But A, since you're multiplying those values times your Y values, it is only going to ever possibly reflect over the x-axis. Now, some people would argue that B can do that, but if B is your base points, is it reflecting? Not really, because it's happening immediately. H and K are not complicated at all. They're still your left-right. For H, remember opposite H, so whatever you see in the equation will be opposite. We'll look at an example down here. And K is your up-down movement. K is exactly what you see. So again, H moves the graph, as we already said, left or right. Okay, and please keep in mind that H is opposite. So that's a very important thing to remember right here. K moves the graph, as I already said, up or down. So I'm kind of duplicating what you see up there. Now, what this is saying is since A is a multiplier, as I mentioned here, if A is greater than 1, like it's 2, it's going to make the points twice as big. So this is going to cause the graph to stretch vertically. Now, the next one always confuses students because they're like, what does it mean when it's saying that the absolute value is between 0 and 1? It's basically saying that A is a fraction and that fraction is less than 1, and that would make things smaller. So an example would be like a third. Well, if I multiply things by a third, that is going to compress it vertically, and that compression is going to cause it to make the graph smaller or compress. If A is 0, I'm sorry, less than 0, meaning negative, it will reflect over the x-axis because remember, A is multiplying the y values, as I mentioned here, and that is going to cause a reflection over the x. If I make all of the y's negative, it reflects over the x. The key points, as we mentioned on the other page, are -1, 1 over b. Always the y-intercept, 0, 1, and then 1, comma, the base. All right, let's start that by just doing this. Like, what are the key points here? The key points have to do with this 3. So for this one, you have -1, 1/3. Then you have 0, 1, and then 1, the base, so 3. When I look at this one, ignore all the mess and just do -1, 1/2, 1 over the base of 2, 0, 1, and then 1, the base. Okay, so go ahead and try that one. Okay, hopefully hit pause. All right, so now if you did hit pause, you'd have -1, 3. Remember, we would reciprocate this, 0, 1, and then 1, 3, the base. Okay, so if that's what we're doing, we did that on the third page, what are we doing here? We're also identifying H, right? So in this case, H is 2 and K is 1. And that's going to move the graph right and up. So let's take a look at what that looks like. Okay, so your normal asymptote is at y equals 0. And then if I put my key points that I have here, -1, 1/3, 0, 1, and 1, 3 on the graph, then what's going to happen is I'm going to move these points, all of them, right to up 1. Now, I know that in other chapters, you may have seen like point multiplication and point addition. We're going to kind of do a hybrid in this chapter, but the basic idea, just to remind you of what you might have learned in Algebra 2, or even Algebra 1, is you move the graph right 2 and up 1. And notice that the asymptote can't move right or left. So I always move the asymptote first as like an anchor, and then I move the points. So right 2, 1, 2, up 1, right 2, 1, 2, up 1, and then right 2, up 1. And your teacher will grade the one you draw the points through. So many students will say, well, how do I know what I get graded by? The one you drew the curve through. So here's a perfect example of kind of like a hybrid of multiplying the points and doing the shifting. So this -1 is multiplying times a, right? And a is a y multiplier. So I can just come and multiply all these by -1 and graph those points, -1, -1/2. Notice I'm using red to delineate. They're not the key points. They are the modified key points. Then here I have -1 and then 1, -2. And you can see that that's been shifted over the x-axis. And then from here, we can move h because h is -1. So now I can take the red points and move them to the left 1. That would be my graph right there. Okay. The last one, again, just doing h and k. So just to kind of get back to the idea that h and k, this would be +2. Remember, opposite h, k is -3. So my key points would be what you see here. I don't have an a to change them. So -1, 3, 0, 1, and then 1, 1/3. Made a little boo-boo there, forgive me. 1, 1/3. Okay, so then we would scroll. That would be the normal graph if I didn't have to do any transformations. But the transformations on this tell me to go right to 1, 2, and then down 3. And it gets a little confusing. So again, I moved the asymptote to -3 first, so I knew where I was going. So right 2, 1, 2, down 3, 1, 2, 3. Right 2, down 1, 2, 3. And then right 2, 1, 2, down 1, 2, 3. And that would be the graph that you would on the graph and show your teacher and you knew what you were doing. All right, so let's take some key information here. The asymptote is always k. You can see it right here on the graph, but if someone asks you the asymptote, you just go, oh, it's the k value. So that would just be y, remember it's horizontal, so y equals 1. This one doesn't have a k, so notice it's y equals 0, it did not shift. And this one is y equals -3. You don't have to make the whole graph to do that. Your x-intercept sometimes shows up and sometimes it doesn't. So here you don't have one, so you would say none. But because I shifted, this one also would not go past the asymptote. But because I shifted this one, it clearly has one right there. So what is it? Well, to find the x-intercept, you need to set it equal to 0. So I'll do it over here. Okay, you set the graph equal to 0, or f of x equal to 0. And you solve this equation. Now, I know you might be able to see it on the graph, but the graph can't really be trusted perfectly. You need to double check it. Remember, an x-intercept means you let y equal 0 or f of x equals 0. So I'm just going to solve this by reversing the order of operations. I'm going to add 3 first. And again, why are we doing that? Well, if you look at the order of operations and you reverse it, then what happens is that addition is at the bottom, and subtraction is at the bottom, so I started there. Okay, so then this is this, and now we have the base, and so we don't have any multiplication or division. You don't divide by a third, that's an exponential. So it tells you right here that to do an exponential, you would log this. So if I log base 1/3, this will cancel, and if I log base 1/3 over here, it comes out to an integer. So as a reminder of how logarithms work, I flipped this over, that's a negative, and 3 to 3 is the first power. So that's actually -1. I just reciprocated it, and it came out to the same value. This would drop down, and then I would add the 2 to both sides to get my final answer, which is what you see on the graph, but sometimes you can't tell, so I'm showing you how to do it. X equals 1, it's right there. Please write that as a 0.10. Okay, so y-intercept. That value, I have no idea what that is. Right, this one you can kind of tell. So you can say, okay, it's 0, -2. So how do you find a y-intercept? You plug 0 in. So for this one, what I would do is I would say 3 to the 0 minus 2 plus 1. So 3 to the -2 would be a value I need to understand how to find. 3 to the -2 is a 9th because you would reciprocate and square. Remember, flip it over and then square it. And then if I add 1, I would get the answer 1 1/9, which is acceptable, but some teachers would want you to write it as 10/9, right? So this intercept, I put 0 in and I got 10/9. Clearly, I can't get that from the graph, so please remember to plug the 0 in and evaluate. This one, we can just go ahead and call it that, it's right there. It's very clear. If you plug 0 in, you clearly get -2 because you get -2 to the first if you put 0 right there. So let's see what happens if we put 0 in this one. So here I would have 1/3 to the 0 minus 2 minus 3. I don't know what it is, it's off the graph. So this would be 1/3 to the -2, which would reciprocate and square, making that 9. And then I would subtract 3 from it. So evidently it's actually at 6, but I couldn't see that on my graph because it's way up here. So what does growth and decay mean? Growth simply means that your graph goes away from the asymptote, which this one does. This one also goes away from the asymptote. That's what's known as negative growth versus positive growth. But you see how this graph goes towards the asymptote from left to right? That's decay. It sometimes is called decay to the asymptote as opposed to these two which go away from it. You can also see it in the end behavior. So please remember that the domain for every single problem on this entire chapter is -infinity to infinity. And then here you're just explaining what the graph is doing. -infinity means left because it's right here. This one's going to the asymptote. So the asymptote was 1. And this one is going away from the asymptote on the right side. It's going away from the asymptote to infinity. That's what growth looks like. Starts at the asymptote, goes to infinity or -infinity. So over here, if you look at this one, okay, we have -infinity here starting at the asymptote. So f of x is going to starting at the asymptote of 0. And then f of x here, again, it's going to -infinity. It's going very far away from the asymptote. Now look at what happens here. At -infinity for this one, right, the graph is at -infinity, the graph is, whoa, it's way high, it's at infinity. But then what's happening at infinity is the graph is going to its asymptote. So just remember that growth means away from the asymptote, where decay means towards the asymptote. And please notice again, this is super important for graphing. K is 1, the asymptote is 1, the end behavior has to do with 1. And if I asked about domain and range, the range would be at 1. So be careful of knowing how to do that asymptote. It does show up in multiple places. All right, there is one more page. Thanks for watching this part.